My name's John Eisen. I'm presenting about functional relational programming, which I'll tell you what that is in a second, and its use in UI frameworks. So when I say UI, I really mean browser frameworks. So we'll talking about those things that you might not know about. I got the date right. That's cool. And that's a link to the slides. I live here. That's my dog. My dog will be in the top. The dog's name is Tyson. It's very cute. Yeah. So we're going to talk about what FRP is. When I say FRP, I'm talking about functional relational programming, not to be confused with the widely popular framework functional reactive programming. It's actually quite unfortunate, but I didn't come up with the name, so blame me. And then we'll talk about some of the stuff. So functional relational programming was introduced in a pretty seminal paper, widely cited, at least by communities I'm in, called Out of the Tarpit. Out of the Tarpit is a paper that tries to consider what's called the software crisis. The idea that software is constantly, is ever growing easier to write, but not very fast. It still takes orders of magnitude longer to write large systems than in some other fields. And the whole thesis of Out of the Tarpit is that there's essential logic in every program that you have to deal with, an essential state that you have to deal with. But if we can somehow separate the other stuff, the stuff that's really just central to the programming language or the framework, or how you chose to implement a solution, the accidental logic, if we can separate that out and push it somewhere where we don't care about, maybe call that the infrastructure, then we'll have not necessarily solved the software crisis, but made it better, made software easier to write. And Marks and Moseley, the authors, they proposed this thing called functional relational programming. A lot of people read this paper and never get to the FRP part, just because it's way back there. In a 60-page paper, it's 2/3 of the way through. So only the most determined really get to read about it. Here's a quote. In FRP, the all-essential state takes the form of relations. That is the relational model as defined by COD. So like the original, kind of the way SQL kind of came out of. And essential logic is expressed using relational algebra. That is, say, derived views on relations. So if you have, we'll have some examples. We'll describe it. And then we can extend that with pure functions. So here's a diagram from the paper, and it says, essential logic is the combination of pure functions and relations. And that is on top of essential state, which is just relations. So we just talk about, like, maybe defining it. If you think of SQL, you're talking about defining your tables. That's your essential state, right? And your essential logic would be all your derived views. And that communicates with other. As you can tell, they didn't flesh out very much what other is. But other generally means like things you're users, right? If we're talking about UI frameworks, we're talking about how do we communicate to users. That's complex. That's complexity that needs to be taken care of somewhere. So they push that in other. And then there's accidental state and control. So in UI, I generally think of this as data syncing or communication or all these things you have to take care of because you're writing a UI framework, but your users don't actually care about, right? So a lot of you have done web programming. Data syncing is a complex problem, and you have to deal with all sorts of issues, but only you care about it. And if your users see it, they don't really care about it. That really defines accidental complexity. Because if your users don't care about it, then you really shouldn't be talking to them about it. So it's something that you want to push away from your mind and push it away from what you do day to day. Ideally, just be taken care of. So the primary goal, as I said before, is the elimination of complexity. So I've gone through a bit of that. So here's an example from the paper. They have a whole example of essential state and essential logic as they see it from a real estate example. So imagine you're building a real estate UI. I have cut most of it out because it's quite lengthy, but I've included some some various things that I think will help define what I'm talking about. So we have here the def rel var. So that's basically, imagine you're just saying, here's my tables in my SQL database. Or here is, so each room is a tuple of address, room name, width, breadth, and type. Now, and then an offer has these different fields. And then, so if you were to query for rooms, you would get a list of rooms, each tuple being of that type. You can extend these views with, and I apologize, I couldn't find a good highlighting for this particular one. But if you can now extend these views in various ways. And I say views because that's similar to the way we think about SQL views, right? It's table-like, but it's not actual data, it's derived. So you can also say derived relational variable, if you prefer. And so extend is a function that adds a field. Join is a function that combines two relational variables. Project is a function that subtracts fields. And there's other sorts of functions in the relational algebra. And the cool thing about this is it's very composable. Like every single function returns a relation, and that can be composed with other relations. You can query any one of them. Just like in SQL, if you wrap parentheses around any select statement, you can select from it. That's kind of what we're doing here, but in a more functional way. And then you can so FRP also includes the ability to set constraints. And this gets a bit more into the accidental complexity part of the question, right? If you're building a real estate application, your users care about what rooms are in the houses, but they don't really care what how I query for the room, right? And that's what candidate key means. Like that's your primary key, right? Or foreign key. They don't really care how you join rooms and properties. Like that's so being able to declaratively state these accidental complexities. That's really, really cool because it allows you to say, here's what I need done. Now, infrastructure, go take care of it, right? The authors keep referring to infrastructure as basically the thing that runs your program. And then you can also specify these more complex constraints. Like this one says you can never have a property with no rooms. And this is just sanity checking. But it would be really nice if we had a whole system that could, on change of data, enforce these constraints declaratively. People have done a lot of work in this space very specifically, but this kind of combines it with a bunch of stuff, saying that these constraints are part of the accidental complexity, or maybe the essential complexity of your application. And then there's some more stuff they talk about. They talk about declaring for the store. This basically means like saying, oh, the room and the floor, they should be denormalized when you store them. This kind of stuff probably doesn't apply very much in UI development. But their intent here is to say that your users don't care that room and floor are stored together or stored apart, but if you need to do it for performance purposes, you should just be able to specify it declaratively. And last but not least, feeders and observers. Feeders would be things that modify state, insert, update, delete in a SQL sense. Observers would be things that modify everything else, not in the system. So when we talk about UI, we're talking about rendering the UI, showing different HTML, or updating a log system on changes. They spend about 2 paragraphs in a 60-page paper talking about this. So it's quite underdeveloped. But this is what kind of matters to me, so I like to think a lot about it. That's Tyson. He's tired. So let's get something. So here's the TLDR. You guys didn't have to pay attention for the past 6 slides, because now I'm going to tell you what they all meant. So functional relational programming is about specifying your state in a relational algebra. It's also about specifying the logic of that on top of that state. So what do you care about? Like if you have a list of rooms in your real estate application, you don't want to show all rooms on the page. You want to show rooms that are parts of houses that have open offers on them, or aren't closed yet, right? And so you have to really build up a bunch of queries on top of that, a bunch of derived relational variables. The observers can listen on a relation, a very specific relation, and then update UI based on that. And last but not least, we can specify all that accidental complexity declaratively, which is somewhat rare in today's systems, I'd say. And then even stepping it further back, what's that essence? We have a separation of data state from how things like look, right? From UI, right? That's going to be the observers. Those are in a different place from where we specify state. And moreover, it's in a different place than where we specify what's interesting about the state, right? That's what essential logic is. It's where we specify what is interesting about this state. What is the interesting way to look at this state? Now, the relational data model is very composable and powerful, so it's useful as opposed to, if you just have a list of documents, you have to do a lot more work to get interesting things out of it. I mean, a lot of it's more built in, but in the relational data model, you can start to compose different views together. Most of this stuff is all pure functions. The only things that wouldn't be pure functions would be these feeders, these things that modify state. And nobody talks about those, so you don't have to worry about it. But ideally, they are pure as well. So my interpretation of it is that they are pure reducers of state. So you take one state, reduce it to a new state, return that. So that's a pure function, and have the infrastructure do the state keeping. And ideally, we would have declarative data constraints, where we can specify this data should not be wrong. So my thesis of this talk is basically that I think a ton of modern UI frameworks do things very similarly to this framework I've just described to you, which almost none of you have ever heard of, right? And the reason none of you have heard of it is because of this, I believe. Like, Out of the Tarpit is published 3 days after jQuery is published. So if we walk back in time and think about what jQuery was like, what the world was like, what the UI world was like, it was so different. Nobody was ready for things like, hey, we should have reactive views on our state, right? Like, people just not ready for that. So everyone forgets about this paper. There's some really interesting stuff in the first 40 pages. I'm glossing over that, right? Everyone forgets about the functional relational part. And if you go search online, you get like 2 Hacker News articles, one side project by me, and another side project by another guy. And like, that's it. So it's like very much like not in the view. But I do think, stepping back a second, where I probably misordered my slides, that we do see elements of this framework in UI frameworks today. And so that's what I'm going to show you for the rest of this talk, which I have about half left, which is good. Well done. So I'm going to talk about Elm, Redux, and OM, and maybe a bonus one if you're lucky. And yeah. So the Elm architecture, if you were at the Elm workshop earlier, you learned about the Elm architecture. It has a model, which is an algebraic data type, where you have the state of your application. You have an update function, which is a pure reducer of state. And you have a view function, which renders from the entire state your entire view. And the underlying infrastructure, the framework of Elm, will take care of calling your update function and keeping your underlying state in a cache. And it will re-render your view. And using the magic of virtual DOM, it will be efficient when it re-renders your entire view. And here's a little bit of code from literally the Elm architecture doc page. But you have it. You can set up your model. That's an algebraic data type. It's a record. You have your update function. You have a type message. These are the allowed updates. Your update function is a reducer. You notice it as type message model. You have your view function, which takes an entire model and returns HTML. Yes, there's more complicated versions of this, but this is the beginner program of that. Right? But it shows how the architecture is set up. So I think that it's really similar to FRP in some ways. I think it has definitely the separation of data in UI. So the view is separate from the update and the model, right? And that's kind of the way observers, right? You can think of the view as an observer in this pattern. And it has these feeders. That's the update function. It's this pure reducer. Every time an event fires in your HTML, like you clicked on something, the underlying framework will just feed that to your update function. So you have this nice separation, which I think is a core part of FRP. And but you don't get subscriptions, so you're not able to say, hey, I want to only change this one thing down here when this particular view of my data changes. You get called when all of your data changes. So, and it is made efficient by virtual DOM. So it doesn't exactly implement FRP, but at the same time, virtual DOM has made that maybe not matter as much. And the logic and the state are usually records and lists of the documents. It is not usually relational, so we're definitely not fully implementing FRP. And a lot of the logic is built into those observers, built into that view framework. So if you have a list of documents and you want to like filter it, you're going to write those filters inside your observer, inside your view function, and that's not necessarily coherent with FRP view, which says you should really separate that out into a composable format like the relational model. Tyson's back. So cute. I literally put them in my talks just so I could really re-energize. So Redux is a JavaScript-based framework based on the Flux architecture, and it's also based on Elm. This is a diagram from the Flux architecture, and it has a similar pattern to what we just saw in Elm, where actions get fed back into something like if you can imagine the dispatcher and the store are kind of like that update function. When you combine them together and you have your view. Redux is pretty is not very verbose, especially when you look at like the Flux website and the examples are entirely too verbose. Redux is very nice. Like you can create this store, and by create store, you're saying, hey, underlying infrastructure, take care of this store for me, right? And you can have to actually do subscriptions and where you can get the state, and you can build things on top of those subscriptions where you can query maybe subparts of your data. So we can now push some of that logic of what do I want to query, what do I want to update on, like just a filtered list to subscriptions. And we can dispatch actions, that's how we make updates. And then we have state reducers, that's like the update function from Elm. So pure reductions of state. And React components render the output, so that, and they do it based on your view. And they can be, the properties of any component could be your entire view, or they could be subsets of your view, which only re-render when certain parts of your data change. So when we talk about how much it's like FRP, like Elm, we get that a bunch of those separations of like, okay, we got the view over here, we got the update, that's good, and we get to add in that we have subscriptions. Now, there's no filtering subscriptions like basic, but you can add it in on top, so you get that nice, but it's not composable. Like when we go back and we look at the way FRP says, hey, you know, if you want to filter and extend your list of properties that are available, you can do that in a very composable way, whereas your subscriptions here in Redux would not be as composable. So that's a drawback. And we get a bunch of essential logic pushed into action handlers, which is kind of nice, but they take the same place as Elm. So in the end, Redux and Elm are very similar, just different languages. So now we're going to talk about Om. Om's really cool. So Om is in ClojureScript, and it has a few things. So that top function read is basically, hey, here's a way to read. So this allows the user, you, to define how you want to read the data. And then mutate is the user definition of how you want to mutate your data. So you can plug in your own mutations and reads there, just like you could with the other two, but it's a lot more explicit about that. You can set up queries, like with def UI, that can be composable. They're not easily composable, but they are composable. So that's a step up that we already have. Is now we have these queries, these which are basically subscriptions. If you look at the bottom one, we have like def UI, which is a React component that has a query, and that query is basically going to inject into the properties of that React component. And so now we have this ability to query a specific part of the data and inject that into one React component in a composable way. So that's the first time we've seen that. You'll also notice like on transact, on clicked, that's throwing off a data change, and it would be fired to the mutate function. One of the cool things about OM is there's a tutorial on the wiki which shows how to include DataScript. And DataScript is a data log for the browser, and it's not the relational model, but it's kind of close. And here's a little bit of code about how we can create or plug in DataScript. But the cool thing here is we can start to say, okay, def method read. So when I want to read the app counter, I'm going to do this data log query for for the counter that I'm specifically looking for. And when I want to mutate, I'm going to update the entity by increment. And so now we're starting to push a lot of that complexity into places where it's a little bit more relational, and we can start to combine these different queries together in a more composable way. So, and I just wanted to really quickly state something about Next, which is very exciting, and it provides it's trying to solve a lot of the problems that the last talk was talking about with data synchronization to the server, and you should go look at it if you're interested. But I believe that's like one of the core accidental complexities, and this is really, and this is a field that really Meteor has tried to solve a lot with their work, as well as Next, and just trying to provide more declarative ways to specify data synchronization. I didn't include too much because the talk's kind of short. And so basically, the cool thing about compared to the other two is data log queries, right? So we get declarative data log queries for observers, and that's a way to push accidental complexity, like, hey, what data does this particular React element care about? We can push that into the React element in a composable way. Cool. All right, so I have a few minutes, so I'm going to talk about FireUp. This is a side project of mine that got me really interested in this topic. And so it implements Cobb's relational model in just straight up in memory. And so you'll notice def relvar, def view. These are things that you've seen at the very beginning when we talked about the actual paper. So I implemented these functions, and you can, using the read and mutate functions in you can just include this particular data model as your query engine. And so you could say, hey, this UI of large rooms, we're going to query for all the large rooms, right? Well, what are large rooms? Well, large rooms are restricted they're all the rooms that have greater than 500 square feet, which is really cool. So like now we get composable, defined, essential logic, right? Like instead of defining what a large room is, what the list of large rooms are, instead of defining that in line or doing a filter in line with the UI, we now get to move that to another file and start to talk about it separately and have that nice separation and composability. So FireUp can be plugged in with it also can be plugged in with Reframe, which is on top of Reagent. And you can get all those great properties of the feeder and observer separation, but now with actually having the original relational model right there. So it actually did work for the talk, right? Mm-hmm. And so just to recap, so FRP's published. It's interesting. Nobody does a lot with it. FRP is now kind of partially implemented in many of the UI frameworks. And the question is, like, what does that mean? Right? This is what you were asking in your head, and what I've been asking for a while. And I think it means that, like, some of the ideas were good. And even if we came to it in a circuitous route, we we have identified ways to build systems that are positive. That's why all these systems kind of look the same. We have this separation of data. We have separation of data from UI. We have, really, we're building towards better ways to compose our queries on top of our data. And I think that one of the reasons that UI frameworks don't exactly implement this stuff is because it's not necessarily the right answer. It's just simply a direction to move in and to experiment in. Perhaps that means it was a good idea. But the original question, the original reason Marks and Moseley developed FRP is to solve the software crisis. Probably not. I don't think that any one framework is really going to solve the software crisis.
You said DataScript was almost like FRP, but not quite. Can you elaborate a little more?
It's a composability question, right? So DataScript, you can take one query in DataScript and then query off of that, but the semantics of that involve like different quoting rules and with Clojure, and that can be it's usable, but it's not exactly like easy.
So I'm next to GraphQL queries like literally compose, and DataScript is not. Is what you're saying.
I'm not saying it doesn't compose. I'm just saying there's certainly like there's not. They didn't build it to compose easily. That's what I'm saying. And if you had something that composed easier, you would have this easier way to build queries on your data up and up and up as they go. So like relational derived views are very useful as you build them out when you have a big SQL table. I think similarly, looking at your data is useful. But I guess that's really Marks and Moseley's reason for creating is because they believe that too. That's all I have. Thank you.